Good afternoon everyone, myself R. Praveen from Biomedical department, final year. Going to explain about the patient monitoring system. Basically it is a 5-para monitor. Now we can see the temperature. It is a basic temperature is 33.3 and it is connected to the patient. Next we can see the respiration, and next we are seeing that saturation of pulse oxygen. It is a fingertip pulse oximeter, and it is a non-invasive blood pressure NIPP. And next we are here connected 5-lead ECG, and we can see the 2 leads of lead 1 and lead 2, and now we can see plethysmography and the respiration. Actually this is a patient monitoring system connected to the patient, and we are here connected to V1 to V6 as the bulb leads. We are connected to V1 to V6, and the clamp leads is connected to the 2 hands and 2 legs, and by the temperature probe we can find the temperature, and by fingertip pulse oximeter we can find the saturation of pulse oxygen. From the ECG leads itself we can find out the respiration rates also. Now I am going to explain about the PFT, pulmonary functioning test. In this we are finding that lung capacity and tidal volume and the gas exchanges. By the inhalation and exhalation we can find out the lung capacity. Now we can see the in PFT systems. We can how to start that. Yeah. By exhalation we can see the graphs, and by the inhalation we can see the negative the graphs of the down of the 0 axis. By this we can find out the lung capacity and the tidal volume.
This is gesture controlled service robot. Basically the main ideology behind this robot is to make sure we create a human free environment where a robot can provide service to patients. So this is basically a pick and place robot where it picks things and places them in place. So
okay, now you are seeing that the arm which is controlled by a gesture, and usually the person is wearing a glove, and you can notice that the glove has a controller and with an RF module. Now the person will move the arm to downwards. You can see that the arm of the robot was moving downward. Now the up. Now the arm will open. Close. Moving forward, moving backward.
Good afternoon everyone. I am Ramesh Gayatri and I am currently pursuing my BTech in Biomedical Engineering in Vignan University. So today I am here to demonstrate about electrosurgical diathermy unit. So this is the electrosurgical diathermy unit. So this is mainly used in the surgeries and hospitals. So usually we use scalpels at the time of surgeries in the hospitals. If we use scalpels, there is a lot of chance of bleeding at the time of surgeries to the patients. So to prevent that bleeding, we use this electrosurgical unit. So here we are having two modes, and we are having two modes: cut and coagulation. So for operating in a cut mode, we have to increase the intensity, and there are two types of electrodes: monopolar electrode and bipolar electrode. So usually we are using the monopolar electrode with the help of this foot switch. So this is a foot switch to cut and coagulate, for cutting and coagulating, and we have increased the intensity, and this is the ground plate. By using this foot switch, we can cut the tissue. By using this foot switch, by using the monopolar electrode, we can cut the tissue, and also we can coagulate the tissue by using the coagulation mode. This is the handheld device. So to reduce the complexity of using the foot switch, we are using this handheld device. So this handheld device consists of two push buttons. This is for cut purpose and this is for coagulation purpose. So by increasing the intensity of the cut, without using the foot switch, by using this push button, we can cut the tissue. And by using this blue button, this is for coagulation purpose, and we can also coagulate by increasing the intensity of coagulation. This coagulation is to stitch the tissue. Change.
Good afternoon, I'm K. Namrata. I'm currently pursuing Biomedical third year in Vignan University. Today I'm here to demonstrate about US ultrasonic diathermy. This is a therapeutic equipment. Which is used to relieve the muscle tissue, targeted muscle tissue, and it is also used to treat tendonitis and musculoskeletal pain. And there are three modes in this US diathermy: continuous mode, pulse mode and sweep mode. And a particular timer is set for to treat the tissue, and intensity is also given to the US probe, which is in direct contact with the skin to treat the targeted muscle tissue. In the continuous mode, we take the water droplets here to test the continuous mode. So if we set the timer and if we give the intensity, the water droplets start to vibrate, which indicates the heat energy, and in this way the continuous mode works. This is used in physiotherapy for therapy. And so if we change the mode again, this is pulse mode. So so here in the pulse mode, for 1 second, a particular number of vibrations are given. Here there are 5 modes. So here for 1 second, when one vibration is given, 1:1 is set. and for 1, 2 vibrations, and for 1 second 3 vibrations. Likewise till 5 vibrations this machine can produce. And likewise this sweep mode is used when we have to sweep through from 1 to 5 vibrations in a single second. One is to 1, 1 is to 2, likewise till 5. In this way it gives the vibrations set here. For 1 second it gives 1 vibration. Likewise till 5 it sweeps and then comes back to 1 is to 1.
Good afternoon. I am Dhanush, studying 4th year Biomedical Engineering. This is EMG trainer kit. EMG means electromyography. It measures the electrical activity of muscles. This is basically how a muscle appears in our body. It consists of many myofibrils. When a muscle contracts, a electrical burst happens in our body and it passes through the bones, and it can be measured through the surface of skin. And the electrodes are placed on the muscle that is required to measure EMG. So here we are using the bicep muscles to measure EMG signal. This is reference electrode, which is used as a ground. So this is EMG circuit. This is the circuit used to analyze EMG signals. This is instrumentation amplifier, filter and main amplifier. Instrumentation amplifier is used to increase the gain of the signal. As we are using biomedical signals, the signals which are generated are very small. So filter helps us in filtering the required signal, and main amplifier amplifies the signal to get proper analysis. This is how an EMG signal appears when there is no muscle activity. And if there is a muscle activity, then the EMG signal gradually changes. You can observe the fluctuations among the signal. As muscle activity is increasing, the peaks also get increased. The frequency steadily changes. EMG helps in diagnosing the nerve-muscle relationship. If there is any dysfunction in nerve or muscle, it helps in diagnosing the abnormality. EMG is used to measure nerve fiber interactions. It helps in diagnosing that dysfunction in muscle or nerves. It helps to analyze the signal for proper diagnosis.
I'm Anandavarsha Kancharla from 4th Biomedical. So today we are going to see about ECG monitor. So ECG monitor is basically a device which we use to measure heart rate or the ECG signals of our heart. So we call ECG as electrocardiogram. We use electrodes to get the input. So here we have 3 electrodes which will. So these are the limb leads which we use to take the input. We'll be connecting these 3 leads to. So these are the 3 leads which will be used to take the input. So 2 of the leads will be connected to your arms, and the black one will be connected to the left leg as a reference. So we'll be using 2 types of configurations, limb configurations and chest lead configurations. So basically this gives you the idea about limb lead configurations, where you connect one of your electrode to the left arm, the other to the right, and your reference to the left leg based on through the oscilloscope. That is the final output of your ECG signal.
This is the arrhythmia monitor. Arrhythmia monitoring is used to find if there are any irregular heartbeats that can be noted through a patient, such as you can see here, they differ in the ECG waveforms. Like if you are suffering from bradycardia, you will have high peak T wave, and then if you are suffering from tachycardia, you will have low T wave, and it differs upon the problem that you are suffering from. As you can see, this is the instrument. Here we take the general ECG signal using these limb electrodes. using these limb electrodes, and the signals will be conditioned, and they will be amplified and filtered to remove all the artifacts and the noises on the background, and then they are processed through this instrument to find out which is the arrhythmia that you're suffering from. See the result in this oscilloscope which is here. Here you can see if there is any waveform changes or any fibrillations, or any you're suffering from any Parkinson syndrome like that. Or if you're suffering from any Parkinson syndrome, you can operate this oscilloscope and adjust so that you can see actual clear wave without any noises and the artifacts.
Good afternoon everyone. I am Ramesh Gayatri and I am currently pursuing my BTech Biomedical Engineering in 3rd year. So today I am here to demonstrate about electroencephalogram. And this is electroencephalogram. We use this on scalp to know the electrical activity of the brain. Here we are using 32 channel EEG. So this is normally placed on the scalp by using hat type of electrodes or scalp type of electrodes or any saline type of electrodes. So the electrodes was placed at frontal, parietal, temporal and occipital places. And these are the electrodes. These are the electrodes. We usually place these electrodes on the scalp on the places of frontal, parietal, temporal and occipital. So here we are using 32 channel EEG system, and we usually place these electrodes on the scalp by using 1020 system. And according to the according to the electrodes arranged here, we used to attach these electrodes on the scalp of the patient. By using this, we can know the electrical activity of brain. And this is nerve conduction velocity system. By using this nerve conduction velocity system, we can find out the electrical impulse of the signal, how much amount of speed it is traveling inside our nerves. Usually we used to place this on the hand. By increasing the amount of frequency, the electric current passes through the skin to know the electrical impulses of the nerve conduction velocity.
So this is patient monitoring wheelchair, where we measure different vitals of a patient.
Here we are using 4 sensors mainly. This is the heartbeat sensor, through which we can know the heart rate of the patient. This sensor is used to measure the pulse oximeter. It is used to measure the saturated oxygen of the patient. ECG monitoring sensor, through which we can measure the ECG signals of the patient. The temperature sensor, through which we can measure the temperature of the patient. We generally place this in the ear of the patient, where we can get an accurate temperature of the patient. Here we are using chest lid configuration. We have placed 3 electrodes in the chest based on 9th triangle, and then through this signal, through this module, we will receive the ECG signal, where the signal will be amplified and filtered, and then we can see here. This is the output of the ECG signal that we are seeing. This is the general ECG signal of the patient that we are having here. As you can see, these are the normal ECG signal, which refers that the patient is healthy.
Good morning, my name is Samyukta. Here I am going to say about BP mission. This is called as BP measurement. So it is scientifically it is called as sphygmomanometer. So we have to place the cuff on the biceps, and we have to place the stethoscope on the bicipital artery to measure the systolic and diastolic value. So we have to give cuff pressure more than systolic values. Systolic value, that is 180 or 170. We have to decrease the we have to release the some cuff pressure. So we have to note the points when
Good morning, I am Prasanna from Biomedical third year, and this is the 70 centimeters muscles with internal organs, different types of organs, bones and muscles, and in this we will see facial bones, and this is the trunk part, and facial bones are frontal bone, parietal bone and occipital bone, and this is the mandible, which is useful for chewing, and these are the lungs. This is the left lung, and this is the right lung, and this is the heart, which consists of 4 chambers, and this is the liver, which secretes and this is the 70 centimeters male with internal organs, and this is the head part, and in head part this is the frontal bone, which is the main part of the bone, and it protects the head part, and inside this we see the brain. It consists of 3 chambers: cerebrum, cerebellum and medulla oblongata, and these are the facial bones, and this is the mandible, and this is the maxillae. Mandible, which is useful for chewing, and this is the trunk part of our body, and this is the left lung, and this is the right lung, and this is the left lung. This is the left lung, and this is the heart, which consists of 4 chambers, and this part is liver part. The function of the liver is which secretes bile, and this is the stomach. This is the duodenum, ileum and rectum. Stomach is useful for to digest the food, and this is the small intestine, and this is the large intestine, and this is the upper limb of our body, and it consists and it is radius, and it is ulna, which is useful for flexion, rotation and extension, and this is the lower limb of our body, and this is the rectus femoris, which is helpful for rotation. It is joined to the knee, and which is helpful for movement and rotation. In bones, bones are useful to store materials, and muscles are used for movement and contraction and relaxation, and this is the total view of our human body. Heart, which consists of 4 chambers: inhalation and exhalation, which secretes bile. This is the small intestine and large intestine. These are the blood vessels, and this is the thoracic cavity. And this is the lower limb, and these are the muscles of our body.
Good morning everyone. My name is Shaviz. I am from 4th year Biomedical. Today I am going to explain the compound microscope. This is the eyepiece, and here we can look at it. We can observe the magnifying lens by the tissues of the human, and this is the coarse adjustment knob, which we will use for adjustment of this, and this is the magnifying lens, which can be used for the magnification of the lenses of the historical slides, and this is for the adjustment. Here we can place the slide, and this is this adjustment of slide, and by rotating and this we can adjust so that we can see clearly image. And this is, it will be having a magnification lens. Those are 20. So here it is a compound microscope. It is used for the study of the examination of the slides, human body and tissue structures. Here it is the eyepiece, which we will use for the observer, and this is the body, and these are the magnification lenses. Here we will use 25x, 10x, 40x and 100x, and here we will place the slide, and this is the adjustment. Like this we can adjust the slide, and this is the arm, which will connect the body piece and the base, and this is the base of the compound microscope, and by using this we can magnify the images, which we will use for the magnification of the human. tissue structures, and by looking from the eyepiece we can observe the tissues by adjusting this knob, and it should be placed here. It is a mirror, it will be placed before the light, and we can observe from this eyepiece like this.
My name is Vignan. I am from Biomedical department. The project we are discussing today is related to vibrating glove related for IT professionals, which is used as a therapy equipment, or the IT professionals can wear and they can directly use this vibrating glove during their working hours. Arduino Uno board which sends the signals, and it is used as a timer, and these are the two inputs which we have given, positive and negative terminals, and we are connecting a 9 volts battery. Here are the vibrating motors which helpful for reducing the pain, and it helps in a therapy purpose also. Here there are 5 vibrating motors connected.
Good morning everyone. This is Supratika from 3rd year Biomedical. Now I am going to perform experiment on blood grouping and bleeding time. First we need to sterilize the finger. We need to sterilize the finger with ethyl alcohol and prick the finger with the blood lancelet for the free flow of blood, and take the blood samples on the slide for 3 drops. Take the slide and blood sample taken on the slide. These are the agglutinogen anti-serums, anti-A, anti-B and anti-D anti-serums. Cover the each drop, place the each drop on the blood sample. Anti-A, anti-B anti-serum, anti-D anti-serum. Mix it well until the blood and serum get splitted. Blood sample is splitted in the anti-B anti-serum added sample, and even though it is splitted in the anti-D added sample, so this is the B positive blood group. We are going to perform experiment on the bleeding time. So first sterilize the finger with the ethyl alcohol and make a prick on the finger. Just prick on the finger and place the drop on the filter paper. For after a while of 15 seconds, and we need to place another drop on the end of the filter paper. For every 15 seconds we need to take the readings. So by the time the time period of the bleeding time is at the time we prick on the finger and the entire time is completed. So until the blood is clotted or fallen on the filter paper, when there is no spot on the filter paper, then the complete time period is known as bleeding time. So here there is no filter paper. So calculate this all 15 seconds, 15 plus 15 plus 15 plus 15 plus 15. So here generally the normal value of the bleeding time is 1 to 3 minutes. Here 1.5 minutes.
Good morning, I am Sevita from 3rd year Biomedical Engineering. Now I am going to explain about skeleton. Skeleton, it consists of bones, tendons and ligaments, and the skeleton has 206 bones, and at birth the child has 270 bones, and as the age grows it fuse and form 206 bones. In the skeleton we have axial part and appendicular part, and the axial part we have skull and ribs and vertebral column, and in the appendicular part we have upper limb, lower limb and pelvic girdle, and in the skull we have frontal part, temporal, occipital and parietal, and this is the mandible, and here we have ribs which is consist of true ribs, false ribs and 2 floating ribs, and the vertebral column which consists of 7 cervical vertebrae and 12 thoracic vertebrae and 5 lumbar vertebrae, and sacrum, and this is the coccyx, and pelvic girdle. Here it consists of 2 hip bones, and this is the humerus, and this is the ulna and radius, and these are the carpals and metacarpals, and here this is the longest bone, femur, and it consists of patella, and again tibia and fibula and tarsals. The main functions of the skeletal system is it protects the internal organs and it allows for movement and also for storing the minerals and nutrients.